we tend to think we're the end of the line, the final product. We look at our cities, our art, our iPhones, and we see the peak. We see the result of a long, hard climb up the evolutionary ladder. Everything that came before us was just a stepping stone, a simpler, lesser version of life, all leading to this, to us, Homo sapiens, the smart ones. But is that true? Like, are we really the pinnacle of evolution? The short answer is no, not even close. And the reason why is more interesting than a simple yes or no. It forces us to rethink what evolution even is. We have this idea of progress, of things always getting better, more complex, more intelligent. We see a picture in a textbook. It starts with a hunched over ape, then a slightly less hunched over ancestor, then another and another, until you get to a modern human standing tall, holding a briefcase or a spear. Now, it's a straight line, a march of progress. That image is one of the most powerful and misleading ideas in all of science. It's wrong. Evolution is not a ladder. It's not a straight line climbing towards a goal. There is no goal. There is no final boss. There is no pinnacle. A better way to think about it is a bush. A massive, sprawling, chaotic bush with millions of branches. Every species that has ever lived is a branch on that bush. Most of those branches are dead ends. They grew for a while and then they stopped. Our dinosaurs were one big, successful set of branches that got pruned by an asteroid. The trilobites were another, dominating the oceans for millions of years before they petered out. We are just one tiny twig on one branch of that bush. We're a recent growth. A very, very recent one. If the entire history of life on Earth was a 24-hour clock, humans would show up in the last few seconds before midnight. We're an afterthought. The other branches on our little part of the bush weren't failures. They weren't practice runs for us, they were just different experiments. Take the Neanderthals. We have this cartoon image of them as dumb, brutish cavemen, but the evidence tells a different story. They were incredibly well adapted to the cold climates of Ice Age Europe. They were strong. They had brains as large as ours, or even slightly larger. They made tools. They hunted massive animals. They likely had some form of language. They buried their dead, which suggests some kind of spiritual or symbolic thought. They weren't a lesser version of us. They were a parallel version, a different way of being human. They were another twig growing alongside ours. For a long time, we coexisted. Sure, we even interbred. Many people of European and Asian descent today carry a small percentage of Neanderthal DNA in their genomes. So in a way, they're not entirely gone. So why are we here and they aren't? Was it because we were smarter? Better? Maybe. Or maybe we were just luckier. Maybe we were better at adapting to a changing climate. Maybe our social structures were more flexible. Maybe we just had more babies. It wasn't a contest of good versus bad, or advanced versus primitive. It was just a complex set of circumstances where one group survived and the other didn't. Their branch stopped growing. Ours kept going, for now. This idea of a pinnacle also gets tied up with another misunderstood concept, survival of the fittest. We hear that phrase and think it means the strongest, fastest, or smartest will always win. But that's not what Charles Darwin meant. Fit doesn't mean athletic. It means fit, in the sense of a key fitting a lock. It means being the best suited to a particular environment at a particular time. A polar bear is incredibly fit for the Arctic. Its thick fur, its layer of blubber, its ability to hunt seals on ice, it's a masterpiece of adaptation. But take that same polar bear and drop it in the Amazon rainforest, it would be dead in days. It's not fit for that environment at all. A jaguar, on the other hand, is perfectly fit for the jungle, but would freeze to death in the Arctic. So who is more evolved, the polar bear or the jaguar? The question doesn't make sense. They are both highly evolved to succeed in their own worlds. Now think about us. We are incredibly fit for the world we have built. Our big brains, our dexterous hands, our ability to cooperate in huge numbers, these traits have allowed us to dominate the planet. We can live almost anywhere, from the desert to the tundra, not because our bodies are adapted to it, but because our brains allow us to create technology. We build shelters, make clothes, and control fire. We don't adapt to the environment. We make the environment adapt to us. That's our superpower. But does that make us the fittest organism on Earth? It depends on how you measure fitness. If fitness means spreading to every continent and having a massive population, then yes, we're doing pretty well. So are cows, chickens, and wheat, but only because we help them. So are rats and cockroaches, who thrive in the environments we create. But what if the definition of fitness is long-term survival? By that measure, we are rookies. We've been around in our modern form for maybe 300,000 years. The dinosaurs were on top for over 150 million years. The sharks have been swimming in the oceans for 450 million years, surviving multiple mass extinctions. They've changed, but the basic shark blueprint is a winner. There are bacteria living deep underground that haven't changed much in billions of years. They are perfectly fit for their environment, and they will likely still be there long after our cities have crumbled to dust. Are we more evolved than them? We're more complex, certainly, but are we better at surviving? The jury is still out. We are a brilliant, explosive success, but we might also be a flash in the pan. Our very success might be our undoing. The same intelligence that allows us to build skyscrapers also allows us to build nuclear weapons and change the climate. So if evolution isn't a ladder and fittest is relative, what are we? What makes us special, if not our position at the top? The obvious answer is our brain, our ridiculously oversized, energy-hungry brain. It's about 3 times larger than you would expect for a primate of our size. It consumes about 20% of our calories, even though it's only 2% of our body weight. That's a huge cost. In evolutionary terms, you don't get an expensive organ like that unless it provides a massive benefit. For a long time, we thought the benefit was just raw intelligence. We could make better tools, outsmart our prey, and solve problems. And that's true. But it's more than that. A bigger brain doesn't automatically make you better. Neanderthals had big brains too. What seems to be special about our brain is its wiring, particularly for 2 things: language and social cooperation. Your language is a game changer. It's not just about warning someone that a lion is coming. It's about being able to talk about things that aren't there. You can talk about the past. You can plan for the future. You can tell stories. You can create myths, laws, religions, and money. A chimp can't explain the concept of debt. A bonobo can't rally 1,000 strangers to build a pyramid by promising them a reward in the afterlife. We can. This ability to share abstract ideas allows us to cooperate in massive numbers. Most animals can only cooperate with a small number of individuals they know personally. A wolf pack has a complex social structure, but it's limited to a few dozen animals. You can't get 100,000 wolves to work together to build a dam, but you can get 100,000 humans to work together to build a city, fight a war, or run a corporation. Why? Because they all believe in the same shared fictions. They believe in the idea of a country, the value of a dollar bill, the authority of a law. These things aren't physically real. They are stories we tell ourselves, and because we all believe them, they have real power. This is our unique trick. It's called cumulative culture. An animal might learn something new, but that knowledge often dies with them or their small group. A clever chimp might figure out how to use a rock to crack a nut, and she might teach her offspring. But that knowledge spreads slowly, if at all. With humans, it's different. Someone invents the wheel. That idea gets shared, copied, and improved upon. Someone else puts the wheel on a cart. Someone else adds a sail. Soon you have a global shipping network. Each generation doesn't have to start from scratch. We inherit the accumulated knowledge of all the generations that came before us. This is why our technology progresses so quickly. It's not because one person is a super genius. It's because millions of minds are linked together over thousands of years through culture. This cultural evolution is now happening much, much faster than our biological evolution. Our genes haven't changed much in the last 50,000 years. We have the same basic brains and bodies as our hunter-gatherer ancestors. But our culture has transformed beyond recognition. That hunter-gatherer, if transported to modern-day Tokyo, would be biologically identical to everyone around them. But culturally, they would be on another planet. So, in a way, we've created a new kind of evolution, a second layer that sits on top of the slow grinding process of genetic change. This is what truly sets us apart. It's not our muscles or our teeth, it's our shared imagination. But this gift comes with a price. Our amazing brains are also the source of our deepest anxieties. We are, as far as we know, the only animal on the planet that is aware of its own mortality. A dog doesn't lie awake at night worrying about the meaning of its existence. We do. Our ability to think about the future means we can worry about it. We can feel dread, regret, and existential angst. Our bodies are also full of compromises. Evolution isn't a perfect engineer. It's a tinkerer. It works with what it has. It slaps new solutions on top of old problems. Take our backs. Walking on two legs was a crucial step in our evolution. It freed up our hands to carry things and make tools. But our spines were originally designed for a four-legged animal. Standing them up on end puts a huge amount of stress on the lower vertebrae. That's why so many of us suffer from back pain. It's a design flaw, it's a compromise. Childbirth is another example. A big brain is great, but it requires a big head. Walking upright requires a narrow pelvis. Trying to squeeze a big head through a narrow pelvis is a recipe for disaster. It makes human childbirth uniquely difficult and dangerous compared to other primates. It's another evolutionary trade-off. We got big brains, but at the cost of painful and risky births. We are not sleek, perfectly designed machines. We are messy bags of evolutionary compromises. We are prone to anxiety, bad backs, and impacted wisdom teeth. We crave sugar and fat because for most of our history, those calories were rare and valuable. Now that they are everywhere, that same craving leads to obesity and diabetes. We have Stone Age bodies and minds living in a space age world. We are not a finished product. We are a work in progress full of bugs and glitches, and the process isn't over. A common misconception is that human evolution has stopped. We have medicine, houses, and grocery stores. The old pressures of survival of the fittest, starvation, predators, disease are mostly gone for many of us. So, we must be done evolving, right? Wrong again. Evolution never stops, it just changes its focus. The pressures are different now, but they are still there. For example, for most of human history, almost all adults were lactose intolerant. After infancy, they lost the ability to produce the enzyme lactase, which is needed to digest the sugar in milk. But about 10,000 years ago, some groups of humans in Europe and Africa started domesticating cattle. In a world where food could be scarce, being able to drink milk as an adult was a huge advantage. It was a reliable source of calories, protein, and fat. So a random genetic mutation that allowed an adult to keep producing lactase suddenly became incredibly beneficial. People with this mutation were healthier, had more children, and passed the gene on. It spread like wildfire. Today, in places with a long history of dairy farming, like Northern Europe, over 90% of the population can digest milk. That is evolution in action happening right under our noses. Disease is still a major driver of evolution. The sickle cell gene is a classic example. If you inherit 2 copies of this gene, you get sickle cell anemia, a serious and often fatal disease. But if you inherit just 1 copy, you don't get the disease, and you gain significant protection against malaria. In parts of the world where malaria is common, having 1 copy of the sickle cell gene is a huge survival advantage. The gene is a trade-off terrible in one context, beneficial in another. As we develop new treatments for malaria, the evolutionary pressure to keep that gene might lessen. Our modern world is introducing all sorts of new selective pressures. What does fitness mean in a society where intellectual work is more valued than physical strength? Our diets have changed dramatically. We sit in chairs all day. We are exposed to chemicals and pollutants our ancestors never encountered. How will our bodies adapt to these things over the next few thousand years? We don't know. And now we are on the verge of taking control of our own evolution in a way no species ever has before. With technologies like CRISPR gene editing, we have the power to directly alter our own DNA. We could, in theory, eliminate genetic diseases. We could also try to enhance ourselves, make ourselves smarter, stronger, or longer lived. This opens up a huge ethical can of worms. Who decides what changes are good? Who gets access to this technology? Could we end up splitting humanity into 2 separate species, the genetically enhanced and the naturals? Well, it sounds like science fiction, but the tools are already here. We are no longer just subject to the blind forces of natural selection. We are becoming the agents of our own change. This brings us back to the original question. Are we the pinnacle? The idea of a pinnacle implies a purpose, a destination. It suggests that the entire 3.5 billion year history of life was a journey designed to produce us. This is just human ego. We are storytelling animals, and we like to put ourselves at the center of the story. But science tells us a different, more humbling story. There is no up in evolution. There is only out. Life doesn't move in a straight line. It radiates. It explores every possible niche. A microbe that lives in a volcanic vent deep in the ocean is not less evolved than us. It is perfectly, exquisitely evolved for its world. A world we couldn't survive in for a fraction of a second. We are just as specialized. We are evolved to be highly intelligent, social, tool-using apes. That's our niche. It's a very successful niche for now, but success is always temporary. The environments change. The asteroid comes. The ice age arrives. The very definition of fit is rewritten. The species that were once dominant become relics, and new ones rise to take their place. There is no permanent winner in the game of evolution, so we are not the pinnacle. We are not the end goal. We are a snapshot. We are a moment in time. We are one fascinating, complicated, and very successful experiment. Okay? But the experiment is ongoing. We are still evolving. Our story is not over. In fact, by taking control of our own genetics and our planet's climate, we may be entering the most dramatic chapter yet. To think of ourselves as the pinnacle is to close the book. It's to assume the story is finished, and we won. But the library of life is vast, and the final pages are not yet written. We are just one chapter. An amazing chapter, full of drama and invention and beauty, but just one chapter. And we have no idea how it ends. The only thing we know for sure is that we are not the end of the story. There is no end. There is only change.